Hello, today I'm going to show you an example of things that can help us find the zeros of polynomials. So the first thing is Descartes' rule of signs. Essentially it says if you have a polynomial with real coefficients and your constant term isn't zero, then we're looking for the variation of signs. The sign is a change from one coefficient to the next, from positive to negative or negative to positive. So if the polynomial is written in descending degree, that means with the highest power, second highest power, and so on, the number of positive real zeros of f is either the number of variations in the sign of f, or is less than this by a positive even integer. We'll explain that in a minute. And the number of negative real zeros of f is either the number of variations of sign of f of minus x, or is less than this by a positive even integer. So let's look at an example here. We want to find the possible number of positive and negative real zeros for this polynomial, x cubed minus 6x squared plus 3x plus 10. Notice that if we look at just the regular function, then it has variations of sign right here. So here is where it changes from plus to minus, and right here it changes from minus to plus. Between here and here, it's still plus, so plus to plus, that's not a variation. I like to underline these. So we found out that there's two variations of sign, and the theorem says that it's either the number of variations in sign or it's less than this by a positive integer. So we essentially count down by twos, and we can't have negative zeros. So we essentially have 2 or 0 if we subtract 2 positive real zeros. If I plug in a negative x, what's going to happen here for my function, so I put a negative x in for the input, is that every odd power is going to leave that negative a negative. Every even power is going to absorb that negative power. Negative 1 squared is 1, so it's going to make this positive. It's going to keep the sign here. And then I put in a negative here. This is an odd power, so we get that negative sign here. So if I look at f of negative x, I get negative x cubed minus 6x squared minus 3x plus 10. So there's only one variation of sign. So what that means is really there's only one possible negative real zero for this function. Let's go ahead and graph it over here to see what it looks like to just sort of verify what's going on. So I'm going to use my calculator and do an x cubed. And I'm going to do minus 6x squared, so I'm looking at the original function. And then I'm going to do plus 3x plus 10. Enter. I'm going to graph this function. And as we see, really this theorem is right. So what it said is it had to have 2 or 0 positive real zeros. Well, I see one here and one here, so there's 2 positive real zeros. And it said that it had to have one possible negative real zero, and there it is right here. So there's a negative one. So that sort of verifies our theorem here, and that's what Descartes' rule of signs is all about. It doesn't really tell us where those zeros are. In a sense, it does narrow them down, though. It tells us the possibilities for them. So I hope this has helped. Thank you.